they ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would.
Hey, you. Yeah, you. Are you lonely? Do you have no friends? Do you have weird boundary issues with your professor? Well, then I have the solution for you. Introducing Alphafour, the friend that you never had, who's always willing to play any game with you, as long as it's Connect 4. It even cleans up its own mess.
Wow.
And not to mention its eye-catching, user-friendly, extremely portable design. Buy now for the discounted price of $399.99 and 9.10. Raspberry Pi not included.
This is the full assembly of our CAD for our Connect 4 robot. So over here, right here, we have the main game board. So this is where the game is played. Up on top of that, we have the dropper carriage, which will move back and forth to collect tokens and drop them for the computer player. Behind the board, we have the mounting tray for all of our electronics. Underneath the game board is where the column blocker belt is. That's what moves to the side to let each one of the columns fall at the end of the game to reset it. Those then fall on top of this wavy conveyor belt in here, which pushes the tokens along one at a time to the sorter. So this sorter here blocks the thicker tokens by this narrow gap here, and the wavy belt pushes them up into this blocker here, which makes the thicker tokens spill out the side, while the thinner tokens continue forward. The thinner tokens then are rotated 90 degrees around this belt right here. So this wheel meshes with the belt and lets it turn 90 degrees to lift up, and then those go through this transparent windowed piece here, where you can see them rising up to the top here, where there's a tensioned idler for the belt up here that recircles the belt back around to the front. The tokens then spill into the storage up here, where they are ready to be picked up by the dropper again. So our system has 3 total actuators, one for the dropper to move back and forth, one for the column dropper belt to drop the tokens at the end of the game, and then one for the conveyor belt that serves for the sorter and for the elevator. Oh yeah, and we do also have one servo to drop the tokens into their columns.
So to code our AI, we use the Minimax algorithm, which is a fundamental algorithm that is used to make decisions in zero-sum games. It was used in the Deep Blue computer, which beat Garry Kasparov in chess back in the 90s. Basically how it works is it creates a cascading tree of every possible game states, assigns a score to each game state using some heuristic. In our case, we basically gave the score of 1 if the maximizing player, us, was winning, or -1 if the opponent was currently winning in that state. So there was no in between to either winning or not, which makes calculating the position a lot faster, but requires us to go very far into the search tree before we can make intelligent moves. In order to do that, we had to make a lot of optimizations. So the first optimization we made was to efficiently store each game state of Connect 4. Basically, we found a way to store it using a 64-bit variable. We used alpha beta pruning to prune off various parts of the tree that were a waste of time. Basically, we used transposition tables to make sure we didn't duplicate any processing. So if there's multiple ways to end up in the same game state, basically we had code to check for that and make sure that it didn't process the same stuff twice. And we use iterative deepening to take advantage of the transposition tables. So the further along in the game it goes, the deeper down in the search tree that it can go. Here's a simplified overview of our electronics. So here are some IR sensors. So there is an LED emitter and a photo transistor. And the photo transistor is hooked up to an analog to digital converter because the Raspberry Pi does not accept analog inputs. And so using that, it's able to sense where a token is placed. All of the code is running on the Raspberry Pi, which is somewhat of a limitation because the processor isn't as fast as the i7 in my laptop. And then the Pi is able to speak to motor drivers talking to 3 different stepper motors. Here's a picture of what all that looks like. And then here is a block diagram of all of the AI and mechatronics code. So basically everything is written in Python or CircuitPython except for the AI, which was written in C++ in order to be a little more efficient.